Hi, this is Billy Scott from OneCodeCamp, and for this video, we're going to create a voting DApp. Let's go. So for this project, we need to have and set up the following tools. First is the metamask, so that we can create our own wallet to enable us to do transactions in the blockchain. Next would be the chain list, which allows us to connect our wallets to any blockchain networks, specifically the Mumbai network. And then we're gonna need this Polygon faucet so that we could request for enough tokens so that we can pay for the gas fees for every transactions that we will do in the blockchain. Then the third one would be the Polygonscan. We need to create an account in here so that we could generate an API key, which we will use later on to our Hardhat configuration. So to do that, just click sign in and then provide the necessary informations. After you click this, click sign up. And last but not the least, we will be using Visual Studio Code. This will be our IDE. This is the IDE that we will use to perform all of the codes and specifically the Hardhat installations. So let's start. Okay, so the first thing that we need to set up is this metamask. And to do so, just click this download here and then click install metamask for Chrome. I do advise to use Chrome for this. And wait for it to load and then just add the Chrome. Then add extension. Wait for it to download, to finish downloading. There. It's going to be added to my extensions here. And there it goes. It's done adding. Now if I check it in here, it's going to show up on the extensions. Now, if I click this extension, I'm going to pin it so that it's easier to access later on since I'll be using it more often. There it goes. Once I pinned it, it's right there. Now, since this is my first time setting up this MetaMask, it would ask me to create a wallet. Now, let's get started. Now, just click I agree to MetaMask, then create a new wallet. So it would just prompt me like this. You should read that, and I'm just going to hit agree. Then for this, I'm just going to create a password. And then I'm going to confirm that. And click I understand. Make sure that I have put check on it. Then I'm going to create a new wallet. Or click the create new wallet. Then for this, I'm going to do the recommendation, which is secure my wallet. For this, I'm not going to reveal it on the video, but click this reveal secret recovery phrase and make sure to save your recovery phrase somewhere, not saved in the computer, but written, so, because this is very crucial. But for this demo, I just use a dummy account. So yeah, let's just copy. I'm just going to copy this. Then once I'm done copying it, I just click next. And then it would ask me to confirm the missing phrases. So I'm just gonna add it. So for my missing phrases, they are okay, so after adding all the missing phrases, I'm just gonna hit confirm and then hit got it. And then it would ask me to install. Yeah, it would prompt me that your MetaMask install is complete. So I'm just going to click next. Yeah, since I'm done pinning it on my taskbar there. So done. And let's go ahead and try it out. There it goes. I'm just going to no thanks to that. So I have now my MetaMask account. And if I click this fox icon, there it goes. I have now my MetaMask account. Just gonna okay, there it goes. I now have my MetaMask account. Now, the next thing that I'm going to do is that I'm going to connect my wallet to the chain list or to the Mumbai using chain list. Now, let's go to chain list. And once I'm here, what I'm going to do is that I'm going to connect my wallet. And to do so, I just need to click this connect wallet button. There. And if it's not working, let me just reload it. Okay. Once it's done loading, I'm going to click connect wallet and a MetaMask notification should pop up. on your screen, just what I got here. Then make sure that my account has a check on it. Then I'm just gonna click next, then connect. Once it's done, my wallet address should show up in here. Then the next thing I'm gonna do is that I'm gonna search for the network that I'm gonna connect. So it's gonna be testnet for now. So I'll make sure to put a check on the include testnets there, and I'm gonna search for the network Mumbai. And once I key in there on search bar Mumbai, this should show up. Then what I'm gonna do is click this add to metamask, and then another pop-up will show up. Then I'm just gonna hit approve, then switch network. And after that, I'll be just go ahead and check my metamask. Here, you have switched to Mumbai. I'm just gonna click got it. And there it goes. I have now, instead of ETH here, I now have Matic. It means that I'm connected to Mumbai. And if I check it in here, see, we're connected currently in the Mumbai network. So I'm just gonna close this. Or you could also put a check on the show testnets. So I'm gonna close this one since I'm already connected to the Mumbai network. And since I have zero Matic, it means that I cannot do any transactions. So to get Matics free, I'm gonna go to the Polygon faucet. And once I'm here in the faucet.polygon.technology, as I can see it in here, there's a network. It's already set to Mumbai, and the token currency is set to Matic. Now all I need to do is paste my wallet address here. And to do that, I'll just click on the MetaMask icon that I already pinned. Then I'm just gonna click this one. This is my wallet address, so I'll just click that to copy it, then paste it on the wallet address. Okay, so it's not doing anything. Let me just try it again. I'm just gonna click this one, copied, and then on the wallet address, just right click, then paste. You could also use this paste. I'm just gonna allow it. Then so from that, I'm just gonna right click. No, I'm just gonna copy this one. So once it's copied, let me just open in here. Let me paste it here. There it goes. Then I'm just gonna Control A, then cut it. Or you could also use a text editor, then just paste it there, and then just click submit. There it goes. It prompts me that I'm about to get 0.2 Matics. Then just hit confirm. Wait for it to be submitted. There, the request have been submitted. And let's just check our MetaMask account. It takes 1 to 2 minutes to reflect, so it's just showing 0 Matic for now. But once it's done transferring, it will show up 0.2 Matics as it is showing right now. So we successfully got the tokens that we requested. Now let's go ahead and go to Polygonscan. So for this, I already have an account, so I'm just gonna log in. So this is my username. I'm just gonna enter my password. And gonna do this CAPTCHA. So once you're done signing up or logging in, you will see this one. Now we will be needing the API keys here, so just reserve this because we were gonna add or do something in here. And once we're done with our Polygonscan, just keep this open because we were gonna create later on the API keys here. Now, the next thing that we're going to do is to do the codings with our Visual Studio Code. Now, in this Visual Studio Code, we're going to start creating our project. And to do so, we need to create a project folder. Just click on the open folder. Then on your desktop, we're going to create a new folder. And we're going to name that folder as a Voting DApp. Now this Voting DApp folder will be our project folder. I'm just going to select that folder. And voila. Now we have our Voting DApp project folder. After that, inside this Voting DApp folder, we're going to create two main folders. So I'm gonna create the first one, and I'm gonna rename it front end, because this front end folder will be encapsulating all the files that we need to build our front end. So I just click this new folder icon and named it front end. Now the next folder that I'm gonna create is the Hardhat folder. And this Hardhat folder will encapsulate all the files that we need for creating, deploying, and verifying our smart contract. So for this part, we will be focusing more on the Hardhat, and on the second part of this video, we will be focusing more on the front end or building the front end. So now let's just keep our focus on the Hardhat by creating our smart contract, deploying it, and verifying it on the blockchain. So let's begin. Now inside this Hardhat folder, we need to install the Hardhat package first. And to do that, we're going to open a terminal. So just select terminal and then click this new terminal. And then we're going to add in some codes in here. And this one. Okay, so to do that, we need to check the directory here. So since here we're still in the Voting DApp and not yet on the Hardhat, let's change our directory to Hardhat folder. So I'm just gonna use the code or the command line cd, which means change directory, then the name of the folder, which is Hardhat. Okay, so I spelled it wrong. Hardhat, that's it, cd Hardhat. Now I'm just gonna hit enter, and as you can see, now we're inside the Hardhat folder. Then the next thing we're gonna do is that we need to generate a package.json file inside this so that we could use we could install the Hardhat. And to do that, just key in npm init-y. So yeah, one of the prerequisites of this is that you need to install the Git inside your system. You need to install Git first. So I assume that you all got Git now on your system. So and going back, now after this line npm space init space -y, I'm just gonna hit enter and wait for it to install or create the package.json. So once you got this on your terminal, and once you open this Hardhat folder, you will see now the package.json. Since we got the package.json now inside our Hardhat folder, we can now install the Hardhat. And to do that, just key in the command line npm install. It's npm space install space 2 dashes save dash dev space Hardhat, and then just hit enter. And this might take a while. Once we're done installing our Hardhat, the next thing that we're gonna install is the tools for our Hardhat. And to do that, we're just gonna key in the following code line. It's npm install it's npm space install space 2 dashes save dash dev space at nomic foundation. There, it's nomic foundation / Hardhat dash toolbox, and then just hit enter. And then we're just gonna wait for it to load and install. And this also might take some time, so I will just skip this part. Okay, now since it's done installing our Hardhat toolbox and we're done installing our Hardhat, now let's go ahead and create our Hardhat project. And to do that, we're gonna initiate it using this code. It's npx space Hardhat, and just hit enter. And also this one should take a while. There it goes. So now we got the Hardhat, and we're just gonna select the create a JavaScript project. As you can see, it's already highlighted, so I'm just gonna press enter, and then it's gonna ask for the project root. So it's still the same. I'm just gonna hit enter, and then it would ask me if I want to add a get ignore. I'm just gonna say yes, so press Y, then wait for it to load, and there it goes. It gives us this notice that our Hardhat project has already been created, and to make sure that it's really done creating a Hardhat project for us, as you can see inside this Hardhat folder, you will see now this following files and folders. We have now the contract folder, the node modules folder, the scripts, test, and the following files. And later on, we're going to configure this hardhat config.js, and also inside the scripts, we're going to edit this deploy.js. But for now, let's start with the contract folder. So let's start with the contract folder. And as you can see, there's a built-in contract here called block.sol or Solidity file. It's .sol. We can just delete this, so just right click on it and then delete it since we won't be needing that. I'm just gonna move that to the recycle bin. And once we're done deleting that, let's clean up our scripts.js or scripts deploy.js here, and we're just gonna delete this one inside this. So we'll start with here up till here, this one. We're just gonna clean this up. Let's get back to it. There it goes, because we will be adding our own code here once we are going to deploy our contract. So yeah, let's start with the contract, and let's get back with the contract folder. Here, I'm just gonna highlight it, and then inside this contract folder, I'm gonna create a new file. So right click, new file, and I'm gonna name it voting with an extension of .sol to make sure that it's a Solidity file. And just hit enter, and I'm just gonna close this deploy.js so that we could focus more on the voting.sol. So yeah, there we go. We were able to install or start our project, our Hardhat project, and we just created our voting.solidity file where we will insert or create our smart contract. And to make this clean, I'm just gonna close this terminal because we won't be needing it for now, since we will be focusing on creating our smart contract inside this voting.sol. So the first thing that we're gonna do or gonna write in this voting.sol or our Solidity file is to first indicate our license. So it's gonna be to /space capital SPDX dash then license dash identifier, and I'm just gonna choose MIT. You can also key in there unlicensed, but I'm just gonna use MIT. And then I'm gonna indicate which Solidity version would be my compiler. So I'm gonna choose, so I can just key in this Pragma there. I'm just gonna remove this one. So I'm just gonna try write Pragma Solidity, then this symbol 0.8.2. That's it. And the next thing that we're gonna do is we're gonna create our contract. So to do that, just key in contract space, then the name of the contract. I'm just gonna name it the same as this file name voting. So contract voting, and then the code block, which is 2 curly braces. And I'm just gonna hit enter to do that. Just control save for now. So we have now the basics of our contract. The next thing that we're gonna do is that we're gonna write code inside this contract to make this functional. Okay, so inside this voting contract, I'm going to create a structure there, a structure or a structure template for each of the candidates' information. Now, to do that, I'm going to key in struct to indicate that this is a struct, and then give it a name. I'm gonna name it candidate, and all struct for a name convention should be starting with a capital letter. And then I'm gonna enclose information of that inside a code block, which is curly braces. And then the first information I'm gonna add there is, of course, the candidate's ID. To do that, I'm just gonna declare a uint to 56 or an unsigned integer to 56 and give it a variable name called ID. Then I'm also gonna have that a string with a variable name, which is for the name. And lastly is the number of votes. I'm still gonna use unt56, the number of votes. There it goes. So we're done doing the struct. This will store each of our candidates' information, and each candidate will have an ID, a name, and the number of their votes. So the next thing that we're gonna do is we're gonna create an array of that, and to do so, I'll just put in the variable or the struct name, which is candidate, and I'm gonna make it an array, and I will assign it as public so that I can view it, and give that array a name called candidates. That's it. And then the next, okay, I'm just gonna put a comment on this one. List of all candidates. There. And then I'm gonna create the variable address, and this would be, and this would have a name of owner, because I'm gonna use that later on, because this variable will save the address of whoever deployed this contract, and that address or that deployer will be this contract's owner. So I'm just gonna give it a comment here that this will be the owner's address. There. Next is we're gonna create a mapping to track and map all the addresses that already that voted here in our contract. So to do that, map all voters addresses, something like that. And to do that, I'm just gonna declare a mapping, and I'm gonna declare all address there, and all address should have an equivalent value of a boolean. It's either a true or false, so it would reflect true if the address or the user already voted, and false if the address hasn't voted yet. And there, and I'm gonna make it public, and to do and call that mapping, I'm gonna name it voters. So I'm just gonna call the word voters to map them. And yeah, the next thing is, of course, aside from the list of candidates, we also need a list of voters. And to do that, I'm just gonna indicate that I need an array of addresses, and I'm gonna set it to public and give it a name of list of voters. And that's it. Then next thing that we're gonna create, so at first I'm just gonna do declare all the variables that we need. So the next variable that we need is, of course, we need to create a voting start and end session. To do that, we need an integer. So I'm just gonna declare uint56 and assign it as public. That would be the voting start, and then uint56. That would be the voting end. That's it. And I think this is the last variable I could think of, is to create an election status. An election status. And to do that, I'm just going to assign a boolean and assign it to public and give it the name election started. So this would be the indicator if the election has started or the election hasn't started yet. So we're done with creating all the necessary variables that we need. Now let's go ahead and create the modifiers that we need for this contract. Don't forget to save. Then let's do the modifier. Okay, so for this voting contract, I'm thinking of two possible modifiers. Now, these modifiers will somehow create as a restriction or a condition before we can execute a function, and we're going to use it later on. And before we discuss further about modifier, you'll get to know about how it's used later on when we use it on the functions we're going to create. But for now, we're just going to create two modifiers. The first thing that I was thinking is to create a modifier to restrict creating votes to the owner only, since we don't want anyone to just create votes, or how do you say it? Yeah, we don't want anyone to start election. So instead of restrict creating vote, it's create an election, or to start an election. Yeah, restrict creating election to the owner only. And to do that, I'm just gonna create a modifier called, and to do that, let's declare a modifier by keying modifier, then the modifier ID or modifier name, I'm gonna set it to only owner. Then I'll use, so this acts like a function, that's why we need an open close parenthesis, and then space, then it should have a code block, and then it always ends with an underscore and a semicolon. There. Now, this is what modifier looks like. And to put some logic into it, I'm just gonna add a code like require require that the message dot sender, this message dot sender is actually the one who's doing the transaction as of the moment. If that is equal to the owner's address, then we can say that this is a condition. Now, if the message that sender is equals to owner, it can proceed. But if not, it will give us this kind of message. You are not authorized to start an election. It means that if this requirement is not met, then it will not proceed. It will just give us this kind of message. But if this requirement is met, then the code followed by this will just continue. And I'm just gonna close it with a semicolon. There it goes. We're done with our first modifier. Now, the second modifier I was thinking is that we could not just vote if the election is not started yet, right? So I'm just gonna create a modifier to check if an election is ongoing. And to do that, same thing that we did earlier, just key in modifier. Let me just scroll it up. There. Modifier space. The modifier name, it's election ongoing. Then curly braces and the ending of every modifier there. And then I'm gonna put a require function. So require election started. There. So it's just gonna ask if election started is ongoing from here. So if election started is true, then it will proceed. But if not, it will give us this message, no election yet. So there it goes. And I'm just gonna close it with, or end it with a semicolon. And there it goes. Now we're done creating our modifiers. The next thing that we're gonna create is the constructor. Now this constructor will run only once, and once it's run, it can only run once, and it's only run at the deployment stage of our contract. And to create a constructor, we're just gonna key in constructor, and then a code block, and add a function to this. Now this constructor, we're gonna add a code in here to assign that whoever deploys this contract will automatically be the owner of this contract. And to do that, we just need to assign the deployer's address as the owner of this contract. To do that, just put the code owner is equals to the message that sender or the transactor. And that's it. We're done creating our constructor. So once this contract is deployed, it will automatically run this code, and we'll set the owner, or we'll set this message sender, or the one who create this transaction or deploy this, as the owner of this contract. And once it's done deploying, this code of line will not work anymore. So basically that's it. The next thing, and then control save. And the next thing that we're going to add in this contract are the functions needed for this to do its job. Now let's go. The first function that I think that I'm going to add in this voting contract is, of course, to start an election. Now to create this function, what I'm going to do is that I will key in function to declare a function, and to make sure that this variable is a function. Then give the function name. I'm gonna name it start election. There. And this start election is gonna accept two parameters. The first parameter is an array of string. So I'm gonna name it string with brackets to make sure that it's an array of string. Then I'm gonna put memory so that to avoid errors. Then that parameter, I'm gonna name it candidates to make sure that this is an array of candidates. Then the second parameter I'm gonna add is the unsigned integer 56 or uint 56, and this will be the voting duration. So as you can see, I named it underscore candidates and underscore voting duration. Now, to use this start election, I'm gonna assign it to public so that it can be visible. And then I'm gonna add the only owner modifier to access this modifier, and then followed by its code block. There. Now, this only owner modifier will run first before we can run the logics inside this start election. So basically, if the only owner here will be accessed, now when we call the start election, it would go first to the only owner, and it would check if it passed the logics inside the only owner, which is this one. So if it meets the requirement, then it will proceed in doing the logics inside the start election. But if the requirement inside the only owner modifier hasn't been met, then it would not continue or proceed to do or use the logics inside the start election. So basically that's what modifiers do. Then inside the start election, I'm gonna require first that you can only start an election if the election started is equals to false. It means that the election hasn't started yet, and you cannot do or start an election while there's still an election ongoing. So if there's an election ongoing, or if the election started has a true value, then it will pass on a message saying election is currently ongoing, and it would prevent this to run the rest of the code of this function. But if the election started, it has a value of false, then it will proceed to the next line of code. Next thing I'm gonna do is I'm gonna clear the list of candidates first, because what if there's an existing list of candidates, then it will create a mess and we'll just add up the new candidates to the previous candidates. So that's why I'm gonna clear all the list of the candidates, a variable or the array here from the array of candidates. So I'm just gonna clear all of that. That's why I use the delete candidates. It will just delete all the elements inside that array. Then the next thing we're gonna do is we're gonna reset all voter status. Since this is a new election, then those who previously voted should have their voter status reset and set to false. And this will be another function. So at this moment, I'm just gonna reset or comment it out, because we will just uncomment it later once we're creating this reset all voter status function. Now after that, we're gonna use the candidates now. So I'm gonna create a for loop. So for uint 256 is equals uint 256I is equals to 0, where I is less than the candidate from the parameter, the length of it, so that length, and if it meets the requirement, then it will increment the I. There it goes. And for every candidates and or element inside that candidates, it will be pushed. So candidates, it will be pushed to the candidates, the one that we created earlier, that has an element or has elements that is a struct that we created here. Let's get back. Now there it goes. Candidates.push. And what I'm gonna push in here is a struct. So I'm gonna create a struct candidate. There, candidate. And I'm gonna assign its properties. So the ID, its ID would be the I, and then comma, the name would be the name that's enlisted on that particular index of that candidate, which is this one. And then lastly, the number of votes. And that number of votes should be set to 0, since it will be default. So once you start an election, everybody has a 0 vote. And then I'm just gonna end it with a semicolon. There it goes. And as you can see, from this ID, name, and number of votes, it just comes from this struct that we created. We have name, ID, name, then number of votes. Let's get back. Now it's gonna do this. I forgot the semicolon here. There. So it will just using this for loop, it will just go through every element of this candidates and push it to the candidates above. And after that, I'm just gonna set the election started to true, since the election has been started once you create or start this election. And then I'm gonna set the voting start variable. It's gonna be the timestamp or the current time that this function has been executed. So it's gonna be block dot timestamp. There it goes. And then, of course, the voting end, it's going to be the block dot timestamp plus, we're gonna get the value of voting duration, and we're gonna multiply it to minutes. So if we start with, let's say 10 a.m. and then I just add here 20 minutes or just 20 as the voting duration. So it's gonna be 10 plus 20 times 1 minute. So 20 times 1 minute is gonna be 20 minutes. So the voting end will be 10:20. That's it. I'm just missing a space here. There it goes. Then end it with a semicolon. And basically that's it. Just gonna remove this. Yeah, there's no semicolon here because it's inside the push. And there you go. Now we're done creating the start election function. And just Control S to save. Then we're ready for the next function that we're gonna add on this contract. So the next function that I think that we need to add on this contract is the function to add a new candidate. So what if there's a new candidate that we would like to add during the election? So we're gonna use this function. Now I'm gonna name this function add candidate. There. Let me just scroll this up. There. So I'm gonna add this add candidate function, and this add candidate function, it's gonna ask for just one parameter, that would be a string. And since this is a string, it's gonna be partnered with memory, and this string or parameter would have a or underscore name. So it's just gonna take the name of the new candidate that we would like to add. Now I'm gonna set this to public there, and then of course I'm gonna use again the only owner parameter or modifier perhaps, and also aside from the only owner, I'm gonna use this modifier. So we can only add or use add candidate once the election is ongoing. So the good thing about this is that we can use multiple modifiers on one function, just like this one. So I'm gonna add election ongoing, just gonna write its name, and then I'm gonna add the code block. Now let's add a logic inside this add candidate. Now first I'm gonna require that the election period has not ended yet. So to do that, I'm gonna create later on another function, check election period there. So it will run this check election period function, and if it returns true, then the election period is still ongoing, and if it returns false, it's gonna give us a message of election period has ended. That's it, and it would stop the code from in this line only and would not proceed. Now I'm just gonna comment this out since we haven't created this check election period yet function. So we're gonna create that later on, and I'm just gonna comment that after we've done or we created this check election period function, just like what we did in the reset all voter status function. So the next thing is I'm gonna push it to the list of candidates. So to do that, it's just gonna be candidate. I'm gonna call on the candidates array. Then I'm gonna use the push function, candidates.push, and inside this I'm gonna create a new candidate, and it will have the following values. So it's gonna have an ID. So the new ID would be the candidate dot length, so from the previous length, because if we add +1 to that, it would miss some ID number. So I'm just gonna use candidates.length. Then I'm gonna add a name on it, and its name, it will be assigned to the name given from the parameter. And last thing, its number of votes would automatically be set to the default, which is 0, and that's it. Then I'm gonna put a semicolon here to end this line of code. And there it goes. We're done with our add new candidate function, and let's hit save. There it goes. And the next thing that I was thinking, the function that we're going to create is, of course, to check the voter status, because we need to make sure that the voter has already the voter either has not voted yet, or if the voter has already voted. And to do that, I'm going to create a function. Let me just put a comment, check voter status there, because we're going to use this function once we do the function to vote, or the vote to function, and we're going to set this as one of the requirements. So let's go. Let's create our function voter status there. And this voter status would take a parameter, which is an address, and I'm going to name that as voter. And then I'm going to set this to public, and since it's not going to modify any, it's just going to read something on the blockchain and then verify if it's true or false. Then I'm just going to set it to view. Then I'm going to use the parameter, or the modifier perhaps, of election ongoing, just to make sure that I'm going to do this voter status check only if there's an election. Then I'm going to return, this function is going to return something, and that something is a boolean. So I use returns, then the data type of what I'm going to return, and then add the code block. Now inside this voter status code block, we're going to add its function or its logic. Now for the logic, I'm just going to use a conditional statement, if. So if the voters, now it's going to check from the mapping here, if you can remember here voters. So we're going to create a mapping. So for every voters that has particular address, it should return either true or false. Now let's get back to the voter status function. And now if the voters with particular address, the address that we got from the parameter, so if that address from the voters is equals to true, then it's going to return true. It means that the voter has already voted. And if not, then return false. Like that. Return false. And then put a, we forgot a semicolon here. So yeah, there it goes. And then control save. There you go. Now we got our voter status. The next thing that we're going to add to this contract is the vote to function. Now to create that vote to function, I'm just going to add a new line of code here and put a comment to vote function there. And I'm just going to add a function called vote to, and then it's going to accept a parameter. It's going to be an integer, an unsigned integer 256, and it's going to have a name of ID, underscore ID. There it goes. And I'm going to assign it to public, and I'm going to need to add up the modifier election ongoing, just to make sure that you'll only be able to use this vote to function once the election is ongoing. If not, you cannot vote. Simple as that. Then add a code block for the logic. And inside this logic, I'm going to create a require. So it's gonna require this. It's also gonna check if the election period is still ongoing. It's gonna run the election period function, and if the check election period returns a true, then it will proceed. If it returns false, then it will relay this message: election period has ended, and it's gonna stop right there. It would not proceed. So I'm just gonna comment this out first, since we don't have any check election period function yet. And then the next thing that I'm gonna require is that if the voter, I'm just gonna, before I put the exclamation mark there is a negation. So if I just put voter status message dot sender, so it's gonna require that the voter status should be true. But if I put a false in negation here, or the exclamation mark, it means it would only ask if the voter status is false. It means you can only proceed to the next following code if the voter status is false or the voter hasn't voted yet. But if the voter status is true, then it's going to send a message of you already voted. You can only vote once. There it goes. And then that's it. That's the last record that we need for this vote too. Then let's go ahead and proceed with the logic. So once you press this vote, it's of course going to add a vote count to a specific candidate. To get the candidates, we're going to use candidates, choose its index or its ID, using its ID. And then we're going to add something, or we're going to increment a 1 to that votes, to its number of votes property. We're just going to use the increment function, which is plus plus, and then end it with a semicolon. Then, after that user vote, we're going to add that user, or we're going to map or track that user. So we're going to assign it to the voters. We will get its address, and we're going to set it to true to make sure that that voter has already voted. And we're going to add it to the list of voters using list of voters.push, and we're going to push its address. We're going to use that later on for the reset all voters status function. And that's basically it. We're done with our vote2 function. Now Control S to save. Then the next is we're gonna get the number of votes. Get the number of votes. And to do that, we're just gonna create a function called retrieve votes. I'm gonna assign it to public. And since it's just viewing something and it would not modify anything on the blockchain, I'm gonna set it to view. Then it will return something. So I'm gonna use the function the returns. And when we use returns, we're gonna add the data type of what we will be returning. So it's gonna be an array of the candidate struct. And since this is a struct, we're gonna add a memory. There it goes. And then with the code block. Inside the code block, it's just gonna return the candidates. That's it. And end with a semicolon, and there it goes. We're done with the get the number of votes, and Control S to save, and there it goes. So the next function that I'm thinking of is the function election timer, because we're gonna time our voting. That's why we have voting duration, right? So I'm just gonna add a comment to monitor the election time. There it goes. To do this, it's not going to accept any parameters since we're just going to call it, and it won't modify anything. So it's going to be public to make it accessible. Then it's just view since it won't modify anything. Then of course it's going to use the election ongoing modifier there. And then it's going to return a number. So returns uint 256. That's it. And then a code block. Now for this code block, it's just gonna return either a 0 or the remaining time. So it's not return, it's returns. There. Okay. Now I'm just gonna use an if conditional statement. So if the block, that timestamp, the current timestamp where we invoke this function, there, block that timestamp. If the current timestamp when we invoke this selection is greater than or equal to the voting end, so it means it's already past the voting time, right? So it's just gonna return, I want it to return 0. I don't want it to return a negative. Now else, if the block timestamp is less than the voting end, it means the voting is still ongoing. It still does have remaining time. So I'm just gonna return the remaining time, and to do that, it's gonna be the voting end minus the current time, or block.timestamp. And that's basically it. Okay, the semicolon should be at the end part, and there it goes. We're done with the monitoring election time function. Now let me just scroll up there. And since I think we already add all the necessary functions that we need, now it's time for us to create those commented out functions, the check election period and the reset all voter status function that we just commented out earlier. So let's start with the check election period function. Now I'm just gonna put a comment, check if election period is still ongoing. There. So function check election period. This is going to be a public, so that it's accessible. Then it's going to return something. It's going to return a boolean. Earlier we discussed it that it's going to return either true or false. Then code block. Inside this code block, the logic would be a conditional statement. So if it's going to call onto the election timer. So if the election timer has been called, and if it returns more than 0, then it's going to return true. There. But if it doesn't return true, then if the election timer has returned a 0, then we're going to set the election started into false and then return a false value. False. There it goes. So basically that's what our check election period function will do. Now let's just comment out. Okay, maybe I'll just comment it out later on after we've done the reset all voters function, so that I'm just gonna go back there one by one. Yeah, so there it goes. After that, I'm gonna create the function to reset all voters status. And to do that, I'm gonna create a function. It's called the reset all voter status. And then I'm gonna set it to public. And for this function, it can only be done by the owner. That's why we insert the modifier only owner. And then inside its code block, it's the logic where I'm gonna run through all of the listed voters. So I'm gonna use the for loop. There. And I'm gonna go through every address listed inside the list of voters and increment here. There it goes. And all the voters with that address, well, we will set it to false. Then we're gonna delete the list, all the voters inside the list. And that's it. And now we're done. Now let's just remove all the commented out function since we're done creating a reset all voter status. Let's just go up there. I'm just gonna uncomment this one. Let's check more here. Uncomment this. This one also, reset all voter status. Let's check if we're done commenting out the things that we need to uncomment. Yeah, I think we're done with the modifier. First function, done. The add candidate, yeah, also done. Third, fourth function, done. And here, yeah, it's uncommented. And that's it. Basically, that's it. We're done coding our voting contract, and just Control S to save. Now we're going to set up our deployment for this contract. And for that, we're gonna have to we'll just close this folder first at the moment. And we're gonna go to the scripts folder here and go to deploy.js. We need to add some codes here in the async function main. And after that, we're gonna configure something in here. So let's start. Okay, to deploy our smart contract, we need to configure this deploy.js file first inside the scripts folder. And to do that, we're going to add the following code inside this async function called main. And the codes are the following. So the first line would be const. We're going to declare a variable constant called voting contract. And it's going to be equals to await hre.ethers.get contract factory and the name of the contract. So this voting here is not the contract's voting file name. It's actually the contract name here. This one. This is the voting in deploy.js get contract factory. So it's not the file name, but the contract name. Then after that, we're going to create another constant variable, deployed voting contract, so that we can deploy it. It's going to be in await. Then we will get the first variable that we created, which is voting contract, and perform the function deploy. There it goes. Now once it's deployed, we're going to console log the contract address of the contract that we deployed, because we will be needing that contract address to verify our deployed contract. And to do that, we're going to console.log, then I'm going to use template laterals, then contract address deployed, and then I'm going to add the value of deployed voting contract, and I'm just going to get the contract address of that deployed voting contract. And to get that, we're just going to use the target, then end it within a semicolon. There it goes. So basically this is the whole deploy.js function. Now before we can totally run this deploy.js, we need to configure this Hardhat config.js first, and we're gonna install the .env later on after this, so that we can successfully deploy and run this deploy.js. Okay, so first is we're gonna install the .env, because once we deploy this, we will be needing the RPC URL, the API key, and lastly is the private key. That private key is essential, and once you deploy this contract, your private key, if you just put it in here or somewhere here in the Hardhat config.js, and once you upload this file, then your private key will be visible to all, and we wouldn't want that because it would take some risk, and that's not advisable, because anyone who got your private key will be able to access your account. So we need to use the .env and make it hidden from everyone, but we're still able to use it. Okay, and to do that, we need to install the .env. To install .env, please open your terminal, then create a new terminal. There it goes. And please check the directory. Since we're still in the Voting DApp, let's go ahead and change our directory to Hardhat. Just use the code cd hardhat, then press enter. Now we're inside the Hardhat folder, and in this Hardhat folder, this is where we will install our .env. And to do that, just key in the following command line. It's npm space install space .env. There it goes, and then just hit enter and wait for it to install. There it goes. Okay, now it's already installed. The next thing that we're going to do is we're going to create a .env file inside this Hardhat folder. So I'm just going to right click on the Hardhat folder, then select new file, and I'm going to name it .env or .env, and hit enter. Now inside this .env, we're going to add the following variables. First is the RPC _URL, all capital letters. Then this would be equal to the RPC URL. After we're done creating this, I'm going to show you how to get this RPC URL. Then on the next line, we're going to need the private key, all capital letters, then private key. So all the value of this is going to be a string. Then the last one is the API key. There. Now, since we're done with our .env, we're gonna get this 3 values. So for the RPC URL, we're gonna get this from the chain list. This private key, we will get this from our metamask, and this API key, we will get this from our polygonscan.com account. So let's start with the RPC URL. Now to get this RPC URL, we're gonna open up a browser here, the Google Chrome. Then let's go to chainlist.org. And once you're here, since we're using the Mumbai network, we're gonna put a check on the include testnets, just to make sure that when we search a network, it's gonna include all the testnets also. So this might take a while to load. There. Once you put a check there, now let's go ahead and search for the network. here, and I'm gonna search the network Mumbai. There it goes. So as you can see, we just need the RPC URL, right? When we search Mumbai, we get this box, Mumbai, with its chain ID. Now just press or click this arrow button, and you will see a list of different RPC servers here, or RPC URL. So I'm just gonna pick one. So I'll just use this, since this is shorter. I'm just gonna copy this, and then once I'm done copying it, Control-C, I'm gonna go back to my Visual Studio Code in the .env file, and I'm just gonna copy this, highlight this, remove, and paste the RPC URL. And that's it. I'm just gonna save. Then the next thing that we're gonna do is add this, or get this private key. Now to get this private key, we need to go to our MetaMask account, and to do that, we need to open up our browser again and go to this MetaMask icon, click on that. And to get your private address, I'm just gonna show this on the demo. I'm gonna blur out mine. Please don't show this private address of yours to anyone, or your private key to anyone, because this is very confidential. And yeah, for your security purpose, do not show your private key to anyone. So yeah, this might load a while. I'm just gonna create a new tab. So I will click this MetaMask icon, wait for MetaMask to show up, and there it goes. And once I see this interface, I'm gonna click this account, and once I got this, I'm gonna click the three dots here and go to this account details, click on that, and I will see this. Now it would show me my QR code and then my public key, and what I'll be needing is the private key. To get that is to click the show private key, and then it would ask me for a password. I'm just gonna key in my password there and just hit confirm. And now it's showing my private key. Now, and I'm just gonna highlight this and right click, then copy. I'll try to paste it here, there, and I'm just gonna cut it. Then I will go back to my VS Code and paste it on the private key. Just leave that in. There it goes. Now I pasted my private key. So the next thing that we're gonna need is to get our API key, and to get that, let's go back to our browser and go to polygonscan.com/login. And then once you're done creating your account, I'm just gonna log in real quick. So once you're logged in, go to this API keys, and then add. I'm just click this add button, and the name is optional, so you can add a name here or not. I'm gonna name it voting, but it's optional. You can just skip it and just click continue. And once you're done here, now I got my API key. So I'm just gonna copy this one there, highlight it, and then copy. And then I'm just gonna go back to my VS Code, and I'll paste it inside this API key. Delete and paste. We're gonna Control-S to save it, and now we're done configuring our .env. So after configuring our .env, the next thing that we're gonna configure is our Hardhat config.js, which is this one. So just click this. So I'm just gonna close this .env since we're done with it. Now, on this hardhat.config.js, we need to configure this module.export, and also we're gonna import or require the .env inside this hardhat config.js. And to do that, under require Atomic Foundation Hardhat toolbox, let's also require the .env. And to do that, just key in require, then parenthesis, then inside that parenthesis is .env enclosed with quotation marks, and then outside, so it's .config, and then parenthesis, then that's it. We're done requiring the .env. And the next thing that we're going to do is modify this module.exports. So after Solidity, there's a comma, then we're going to add a new one. It's networks, then a colon, and it will have a value, and then the next one would be Etherscan, and then it's also gonna have another value. That's it. Now let's add value to the networks first. Now inside this networks, there's also gonna be another key value pair, and the key would be Mumbai, since that's the network that we're gonna use. And then that Mumbai will have a value. Now inside the value of Mumbai, we're gonna have two value pairs, which will be the URL And that URL will be the RPC URL of our network, and we're going to get that from our .env file. And to get that from the env file, we're going to use this code, process.env dot the variable from our .env. If you can remember, it's RPC URL, then comma. Then, oh, I place it in a different line, so I'm just going to cut it. It should be the value of our URL. Now, the next key is accounts. Now, this accounts will have an array value, and this array value is coming from the process.env.private key. So as you can see, you can actually use directly or paste directly your private key in here and also the RPC URL, but for security purposes, we're doing this because we don't want anyone to get your private key from your code, right? But this .env, even though if we uploaded all of this on the internet, this .env will not be visible to anyone. So yeah, that's why we're using this. And to call that private key from the .env, we use process.env, then the name of the variable where we stored our private key. So after this networks, after we configure the networks, the next thing that we're going to add is the Etherscan. So inside this Etherscan, it's going to have a value, key value pair, and it's going to be the API key. And this API key will have a value of process.env.api key. As you can see, these are all from our env file, the RPC URL, the private key, and the API key. Now we're done configuring our hardhat config.js. The next thing that we're going to do is going to go back to this deploy.js so that we can deploy now our contract. Now, the last thing that we're going to do before we can deploy our contract is first to compile it. So now let me just close all of this terminal to make a cleaner state. I'm just going to add a new terminal there. And I need to change my directory first and go to the Hardhat folder. So to do that, just key in the command cd space Hardhat, which is the name of our folder. And then hit enter, and once we're here in the Hardhat folder, we need to compile our contract first. And to do that, we need to key in the following command. It's gonna be npx space hardhat space compile. And this npx hardhat compile command is going to compile all our codes to generate an API and etc. So you will know that it's done compiling our contract once you get this compiled one Solidity file successfully. Now, after compiling, the next thing we're going to do is we're going to deploy it finally. And to deploy our contract, all you need to do is key in the following. It's npx hardhat. So yeah, it's npx space hardhat space run space scripts /deploy.js, our deploy file. So it's scripts /deploy.js, then space 2 dashes, then network space Mumbai, which is the network that we're gonna use, and then hit enter. And this might take some time, so let's just wait for it, because once it's done deploying our contract, it's gonna console.log our... Okay, so we encountered an error. Oh, okay, now I see why. So I checked here, it's target, so it's a typo. It should be target. Now let's try it again. Let's key in the code. It's npx space hardhat space run space scripts /deploy.js there, and space 2 dashes network space Mumbai. Now let's go ahead and run this to deploy our contract. Hit enter. Wait for it to load, and it should console.log this one once it's done deploying. Okay, so we're just getting an error. This is an RPC error, so let's just wait for a while, because it just says that too many requests error received in the RPC URL. It might have been that our RPC URL has some traffic on it, so let's just wait for a while. Then let's try it again. Let's wait for it. So there it goes, it's done compiling. Now you can see there's a line here that says contract address deployed, and it shows the contract address. Congratulations, we just deployed our very own contract to the blockchain, and after deploying, we need to verify it. And to do that, we're just gonna need to copy this contract deployed. There, just copy it. And then on your deploy.js, paste it and comment it out. Because we're gonna need this contract address to verify our smart contract on the blockchain. And to do that, on the terminal, just key in the following. It's npx space hardhat space verify space 2 dashes network space Mumbai and space our contract address. Now let me just copy this, and then I will paste it here, there, and then hit enter. Wait for it to load. And once it's done loading, it will give us a prompt that, see, it's for verification on the blockchain explorer. It's waiting for the result, and then it will give us this link where we can check our deployed contract, our deployed and verified contract. So I'm just gonna copy it and paste it here and comment this out. Now we can go to this link by copying this here. Since we already copied it, let's go ahead and open our browser here, and I'm gonna open that one, and if I paste it here, it should show up something like this. There. So as you can see, our contract now has a green check. It means that it is verified. See, contract source code verified. And here's our smart contract. And there it goes. Congratulations. We're done creating the backend part of our Voting DApp. And also this is the smart contract management. Now let's go and watch the part 2 to integrate this smart contract to our front end. Thanks for watching.